Welcome in to another new episode of the Materials Performance Interview Series. My name is Ben Dubose. I'm a staff writer for MP, and on today's episode, I'm joined by Bo Anderson, product manager for TSA, that's thermal spray aluminum, with Integrated Global Services, which you also know as IGS. Bo, welcome to the podcast. How are you?
Oh, I'm good. Thank you, Ben, for inviting me. I'm
Thank you
thrilled
for
to be here.
Thank you for joining. And for anyone listening, both Bo and myself are based in Houston, so it's been a heck of a week trying to schedule this podcast given the power and water outages and this just the absolute crisis that's going on in Texas right now with regards to the winter storm and all the related effects from losing power for days. But as of Friday afternoon, both myself and Bo are fully back online, so we were able to get this podcast scheduled. And what we're going to try to do today, we'll talk a little bit about the thermal spray aluminum technology, again, TSA, but there's also a very interesting case study that IGS recently did with Nigeria LNG talking about how this is actually applied in the field and some of the unique benefits of this technology. We'll get to that as we make our way through this. I suppose we'll call it a case study podcast. That's something that we do. We talk to various experts in corrosion control, but we also want to break down how these technologies can be applied from time to time, and this is one of those. And I think it's pretty interesting why it offers benefits for that type of environment. We'll get to that, but I think a good place to start off, Bo, tell us a little bit about your role at IGS. For anyone that's unfamiliar with you or the company, give us a little bit of background about the types of services that you all provide as it pertains to corrosion.
Basically, IGS is providing a lot of services to the oil and gas industry plus other industries, and we do different kinds of coating. We have high velocity thermal spray, which would be zinc, alloys, and stuff like that. We do internal corrosion protection in pipes too. But my job is to do the TSA as a product manager, which means I'm on the technical side of business development, really. So that's what I'm doing. And I don't know if I should go into what TSA is, just a brief overview.
Yeah, sure.
Okay, so TSA is a pretty common technology, really. It's globally accepted to mitigate CUI, which is corrosion under insulation, and it is, I would say, enthusiastically supported by all the petrochemical majors, also in the oil and gas industry, Shell, BP, ExxonMobil, and so on. TSA is a very well-proven technology, and it's been in mainstream really for at least the last 50 years, but the first TSA was done about 1893, so it's been around for a long time.
What are the benefits as far as the implementation? Because the writing that I've done about TSA, what it looks like to me is that one of the benefits is that there's not necessarily the same type of downtime for a plant that has a clear economic incentive to remain operational. I know you all at IGS work a lot with LNG, refineries, petrochemical plants, those types of environments. What is unique about the implementation of the TSA technology relative to some other protective coatings or general anti-corrosion solutions that are out there?
The uniqueness is not so much in time, because it's more or less the same time as painting, really. It won't take more time than that. The unique thing is we put on a aluminum layer, really, that completely connects to the metal, to the pipe, which means that there's no way we can get any humidity or corrosion under there due to the humidity. And it's lasts for a long time.
Yeah, how long does it generally last?
Well, compared to let's compare to what they usually did would be a paint to protect it. A paint has to be reapplied every 5 to 10 years unless you get some very big problems, which I'm sure we're going to talk about a little later. But TSA, if it's applied correctly, it will don't need any inspection or maintenance for at least 20 years.
Okay.
And when we say inspection and maintenance, then we also mean that you only will inspect it after 20 years and see it's still okay, because if it's applied correctly, it will be okay. And then it can last another 20 years before you inspect it again. So in terms of longevity, it's really good compared to paint, because you have to apply it one time. It might cost a little more to begin with. I mean, it's not really a lot more it will cost, but a little more to begin with. But since you don't have to do it again in 5 or 10 years, yeah, you certainly save money in the long run. Plus, you're sure that your equipment is protected.
What's the benefit specifically for downstream oil and gas? I know that's a big focus for you guys. Why does this make sense for them specifically in that type of environment?
It makes it makes sense for them, and it makes sense for any kind of production that is sending gases or liquids through pipes under high pressure and usually high temperature too, because in that case you get humidity on the outside of the pipe, no matter if it's, well, it will be insulated, but it will come under the insulation, and that humidity you get there is going to do corrosion or rust on them and deteriorate the pipes real fast. So in those kinds of environments, it makes perfectly sense to use it.
So what is the IGS model? Because I know this is different than a typical job using protective coatings. Obviously, there's the manufacturer of the coatings, and then you'll have a contractor or someone that's trained to apply those coatings. What's the relationship that you guys have? I know that there's a training component to it. Obviously, you manufacture the technology, but what's your role as far as supervision, training of the application to ensure that this is applied correctly?
Well, we have training classes for technicians. We have trainings for
Okay.
supervisors. Yeah, so everybody needs to be trained to do it. And of course, IGS, we pride ourselves to be a high-end service provider. So we make sure the quality is on top on everything.
Okay. With that as the backdrop, I want to transition to the case study that we led off this podcast discussing, that being Nigeria LNG. What were some of the issues before they turned to your TSA solution? What were some of, or I guess let's start with the background of the plant, and then what were some of the issues that they were having with their original form of corrosion protection?
Well, NLNG was established in 1989, and in 1997 they started their first train of liquefied natural gas on Bonny Island, which is on the side of Nigeria, and out in the water. So that means they have a lot of hot, humid, and very salty environment. So salt is of course a very big issue too, if you have that in the air all the time. Anyway, what they did back then was they protected the pipes, the vessels, and heat exchanger, but they did it the way that was the standard back then, which was to paint them. And then, of course, cover the paint with insulation. But now, 20 years later, they find out that the CUI has turned into a very, very big problem for them. And a lot of their pipes were not bursting yet, but they were about to. I mean, it was like very close. So they couldn't ignore that problem, because that could result in fires, explosions, environmental damage, loss of life, loss of profit, and production loss, of course. So they were kind of forced to do something.
You mentioned earlier that TSA is at least a little bit more expensive. Why were they willing to make that investment? What was it that convinced them that they needed to take an extra step in terms of being proactive and going with that type of technology?
Well, they obviously considered to repaint again all the piping, either with a similar paint or a new kind of paint. But They considered that, but then again, they realized they would have to redo it again in 5 to 10 years, unless they wanted to be in the same situation they were in now. And one thing they really don't like is uh, to have to stop the plant all the time. So they decided to look at TSA instead because they knew that it lasts a lot longer. And then we looked at that.
So, with regards to TSA, I know that the benefit to them, as I mentioned earlier, it can be applied in an online environment, but there's also, and certainly being applied in an online environment, that's how you can recoup a little bit of cost savings, but there's also some safety concerns with that. How did you all address that fear on their end that they could be in an online environment and that you'd be able to apply this new system?
Well, that's the thing. In terms of doing TSA, I mean, like I said earlier, it's a common technology. So basically, there's a lot of people out there doing TSA. So IGS is uh, positioning ourselves in a different league because we are doing something nobody else is doing. And what we are doing here and what we did develop specifically for LNG really was that we had to do the TSA in a live environment, and in a live environment when there is pressure inside the pipe. What could happen is at a time when, especially when you are blasting before you do the TSA, you could get a small hole, and the small hole will result in a lot of gases coming out in a real fast time. And this gas would be either explosive or highly flammable. So in case of that, and we are on a live plant, then the objective would be to keep it away from any, what would you say, outside source of ignition, like next tower over, there could be somebody, or somebody was doing something and dropping a hammer, and there was a spark. I mean, whatever, a lot of things could happen. So what we did was to design a system, and the first thing we did was to make sure we could contain any possible leak, and we did that by erecting a nearly airtight habitat, or also known as an enclosure. Nothing will ever be 100% airtight, but we try to do it as much as possible. Of course, a nearly airtight habitat gives a lot of other challenges. I mean, there's issues with blasting, which produces a lot of dust. So blasting inside an enclosed area will make it almost impossible to see anything. Um, Also, in case of a leak, like I said, that will fill the enclosure with gas in no time, and that would work in there would have to get out real fast too. And of course, it gets very hot in there. So our solution was to create a patent pending ventilation system for this, something nobody ever did before. I mean, the habitats in themselves are well known in the industry,
Hmm.
mostly used for hard work, but also used with positive pressure, which means it would keep out gases. But in this case, we have to keep gases inside. The way we did this in a short story is we used an HVAC system to introduce cool and dehumidified air into the habitat. That means, of course, it's more comfortable to work in there. You get fresh air, and you get air
Hmm.
without humidity, which is one of the things that is necessary for TSA to keep the working condition within certain humidity limits and certain temperature limits. So we get that with the HVAC system. Then to get the dust out, from the blasting especially, we used a dust collector that is extracting the air out to a safe area. By doing this together and the way we did it, we created a negative pressure atmosphere, which means that everything will stay in there as long as the system is running.
How?
Um,
Go
Sorry.
ahead.
Oh yeah, well, the system as such is basically designed all the way around to address the concerns from NLNG and from others about safety. So it's designed as an emergency shutdown system that continuously will monitor everything that is going on inside the habitat, but also in the area outside the habitat, because we want to know if we get gases from other places that could get close to us. But with the system monitoring this constantly, we will also be able to instantaneously shut down everything. I mean, any work inside, outside the habitat, we can close everything down in case we get a leak or we get another kind of alarm. I mean, an alarm will trigger the shutdown for sure.
How did this get done, this type of work, before you had this system? Was it during maintenance turnarounds, I'm guessing, at the plant? Basically, what was the process for you all or anyone providing the TSA technology, the application of it, if this system didn't exist? Would they have to wait for a turnaround, I'm guessing?
Yeah, in most cases they would have to wait for the turnaround, and in the turnaround there's a lot of other activities going on. So
Sure.
that wouldn't be a lot of job or a lot of TSA that could be done in that period of time, because it would be in a limited area and other activities going on. And that was of course one of the things that NLNT was concerned about too, because the plant is 20 more than 20 years old, and now and it consists of 6 trains, and all of them need to be fixed up with TSA, so to speak. And they made a conservative estimate on that, saying that it would take them at least 30 years to do TSA on all 6 trains if they had to do it through turnarounds.
Jeez.
Yeah, so when we gave them the solution, we could do it online in a safest possible way. And in that case, we expect to do it between 6 and 10 years instead. It's still a lot of time, but there's also a lot of stuff to be done on that place.
It's
But before, yeah, but
it's a lot more realistic than 30 years, I'll tell you that much.
yeah, it is really. Um, and and the thing is, before they did this, they did it in turnaround. Now the benefit for them, apart from going from turnaround, that is they take it over to maintenance, and that moves the budget from the turnaround to the maintenance, which
Yeah.
is a lot easier. It's a lot easier to get money for maintenance than for turnarounds.
So the recent project that you all completed, I mean, it was basically a pilot project on one of the trains, right?
Yeah, and it was only on a part of the one of the trains. Yeah.
Yeah. So if it takes them 6 to 10 years, generally it sounds like any given train, considering the logistics, obviously I'm sure conditions are going to vary from one to the other, but it sounds like each train would generally take like 1 to 2 years. Is that a fair ballpark?
Yeah, it is.
Okay, just curious. And obviously there's going to be variance from one to the other depending on the specific needs. What are some of the challenges when you all are in that environment? I know you've completed the pilot project, but you're going to have more as well. Nigeria LNG, there's a lot of factors at play. The African environment. What are the unique things that you're trying to overcome when you're applying this new TSA system for it to work in that type of environment?
Well, there's basically 2 things. One thing is climate, really. Climate with high humidity, heavy
Right.
rain, and thunder almost every day. I mean, they are in the area where you have rain almost every day, a lot of rain. So obviously, one of the good things about our solution is you can actually perform this in all kinds of weather because you're inside.
Okay.
Okay,
Yeah.
the other thing you have to work with in a country like Nigeria is they have some rules about local content, which which is understandable, but that also means we need to utilize local technicians, and we obviously have to train them, and there's some knowledge transfer so they can be better in the future. But I mean, it's not a big challenge, but it's something you have to consider, that you will have to use time to do that, to train the locals.
Yeah. how pleased has the client been in LNG? What kind of feedback have you gotten as far as your ability to overcome those challenges and perform the work?
Well, as far as it goes with our safety solution for this, they were very, very happy. I mean, we certainly did all we could in the right way, and we performed better than expected, I would say that, and that is why we also expect to go back and do hopefully do most of the other 6 trains.
Just waiting on authorization from them, I assume. And I'm guessing, has the pandemic slowed it down at all?
Yes, I mean, NLNG has more or less been shut down.
Gotcha.
Uh, like, of course, you know, international travel is really, really hard. So right now
Understood.
we are kind of waiting a little bit.
I should have asked you earlier, but when you were explaining the rain and thunder almost every day and the climate considerations at play, what is it about the TSA that makes it um, something that can be handled in that environment? Now, I know you're sort of creating the indoor containment anyway, but what is it about the technology that allows it to be applied in unique environments such as that?
Basically it's basically it's melted aluminum that is being shot out and applied. You can do that, but of course we couldn't do that in heavy rain, so you
Sure.
had to go it inside. But yeah, it will work great in an environment like that. That's exactly what they need.
Okay. Just trying to understand a little bit and paint a picture for how it works. Anyway, I think this is a good place to wrap up. Certainly, it's a fascinating technology and a useful case study. Anything about this project that we haven't discussed in the last 20 minutes or so that you think our listeners might want to know, or any lessons learned from this as you hopefully do the other 5 trains of the project?
I don't think we are missing anything, not right now. I mean, everybody is welcome to contact me or contact us, and we can give you a lot more information.
Sure. Okay, then let's leave off there. What is your contact info, or for IGS, how can folks get in touch with you if they want more information or resources?
Well, basically we have two options here. One option is to go to our website, which is integratedglobal.com, where there is a lot of info, also on other info solutions. There will also be contact info. Anybody is also welcome to write me on my email, which is bo.anderson@integratedglobal.com. I will just make sure to tell you that Anderson is spelled with an E and not an O.
There you go. Andersen. So yeah,
E.
and Bo, of course, just BO. So anyway, Bo, with that, we'll wrap up. Thank you so much for
All right.
joining the podcast.
Okay, thank you for letting me in.
Yep, absolutely. And for Bo Anderson, my name is Ben Dubose. Until next time, this is where we'll break. If you want more information, Bo mentioned how you can get in touch with IGS. For us at Materials Performance, just visit materialsperformance.com, and you can also check out amp.org. That's the new website for the Association for Materials Protection and Performance. You can get all sorts of corrosion control information there about the new association, the combination of NACE International and SSPC, the Society for Protective Coatings. Anyway, for Bo Anderson, I'm Ben Dubose. Thanks for listening, and please come back soon for another episode of the MP Interview Series.